Hello, everyone. Welcome to AWS Summit 2022. So before we start our session, just take a quick poll. How many of you here are a data scientist who regularly work on machine learning? Perfect. Okay. Welcome to today's session with the topic, Simplify ML Workflows with Amazon SageMaker Studio and Amazon EMR. Myself, Kalyan Janaki. I'm a senior technical account manager at AWS. So the content in this session is primarily focused for two audiences. The data scientists who want to simplify their ML workflows without having to juggle between different tools and interfaces. And secondly, for data platform administrators who want to simplify their tooling and standardize data analytics and machine learning onto a single integrated development environment. Let's look into the agenda. So we'll start off by discussing a brief introduction to Amazon SageMaker Studio and Amazon EMR. Then we'll talk about why do a data scientist need an universal notebook? So what is the necessity to have a single notebook both for data analytics and also machine learning? Then later part of our session is mostly a pre-recorded demo on how to use this feature. So we'll have 4 demos, and then finally we'll end the session with a consolidated demo of building a machine learning model. So let's get started with a broad introduction to SageMaker Studio. So SageMaker Studio is the first fully integrated development environment for machine learning. So SageMaker Studio provides a web-based visual interface addressing every step that's needed for machine learning model, whether it can be like data preparation, model training, model deployment, and model monitoring. Some of the notable features of SageMaker Studio are elastic and shareable notebooks, automatic model creation to reduce the barrier for your business and get benefit from machine learning, experiment management to capture, organize, and compare different steps of model iteration, automatic model tuning using hyperparameter optimization, a debugger that can debug and profile your model training jobs, a model monitor that can continuously monitor your production jobs and look for data quality drift. So the features that you see on this slide are not the comprehensive set of features. So please visit aws.amazon.com/SageMaker to understand the entire set of features that SageMaker or SageMaker Studio can provide. So let's jump into and dive what exactly a SageMaker Studio notebooks, what are the features of the SageMaker Studio notebooks. So notebooks are actually integral part of SageMaker Studio, powering and complementing the rich set of features that we discussed previously, and making it easy and providing very easy experience for machine learning. So basically, you can start off the notebook on SageMaker Studio without having to spin up the compute resources in advance. With one single click of a button, without having to wait, you will have a notebook instance come up for your work. So while working on this notebook, you can quickly dial up and dial down the resources for your notebook. Like, let's say if you are trying to want high performance modeling, you can quickly add more vCPUs and memory for your notebook. And you can dial down the resources, and then this is completely pay-as-you-go model. So you only pay for whatever the resources that you have used during your machine learning model development. So you can completely customize this notebook as per your organization needs. So you can bring your own images, you can bring your own plugins and extensions. So what are the customizations that you want to perform for SageMaker Studio notebooks can be completely automated using the lifecycle configuration feature. So SageMaker Studio notebooks can be very easily shareable. So if you are working in it as a team of data scientists, so a data scientist working in your team can share entire snapshot of his work to the senior data scientist and get a constant feedback. So these shareable notebooks we've seen have been helping the data science teams to fastly progress towards the data science projects. Finally, your data platform administrators can manage and access permissions and take complete control on who can share the notebooks, who has access to what notebooks, and what images a data scientist can use while he creates a notebook. So these are the quick introduction and some of the deep dive features that SageMaker Studio notebooks provide. Moving over to Amazon EMR. Amazon EMR is an easy way to run big data frameworks on AWS, whether it's an Apache Spark, Apache Hive, Flink, or any of these open source big data frameworks. With just a single click of a button, you can spin up a cluster with all these different big data frameworks installed on top of it. A cluster can be 10 nodes, 1 node, 100 nodes, or 1,000 nodes, or it can be a cluster with an auto scaling that can scale up and scale down the resources as per your workload. One of the big things about EMR is we keep up to date with the latest open source version within 32 or 60 days of its release. So EMR supports wide variety of EC2 instances. If you are working on a compute intensive job, you can choose your cluster with the compute optimized instances. If you are working on processing a huge amount of data of terabytes or petabytes using Apache Spark, you can choose an memory optimized instances. If you are working on a deep learning model, it's allow you to create cluster using GPU instances too. So the EMR version of Spark is, we have compared it with an open source, and EMR version of Spark provides 2.4x faster performance compared to an open source version of Spark. So customers using EMR get this additional performance benefit while doing their data processing and data preparation jobs. So now that we've seen the brief introduction or broad capabilities of SageMaker Studio and also Amazon EMR, let's talk about why would we need an universal notebook. So while we see some organizations consider data engineering, data analytics, and data science as a siloed functionalities, we are seeing a lot of organizations who consider data preparation and data analytics as a foundational components of any machine learning model development. Even though organizations have data engineering teams that they are preparing data needed for machine learning engineers, we see many times a machine learning engineer, when he comes to develop a model, he might not, engineer might not have a data available ready to feed the model. So we see a machine learning engineer spending a lot of time on data analytics, data preparation, and data visualization. So today, often we see data scientists use different tools and different workloads to perform these tasks. So when they want to process huge amount of data, they have to navigate to an EMR cluster, process the data, and then navigate back to the SageMaker and try to work on machine learning model. So we see data scientists spending significant amount of time navigating between these different tools instead of being productive on actually concentrating on machine learning model tuning and development. Administrators, the data platform administrators in an organization, on the other hand, are looking with a way to standardize both data analytics, data preparation on machine learning, and consistently apply security and access control permissions across both the data analytics and machine learning environment. So we wanted to introduce this new feature of universal notebook, wherein which from a same notebook, a data scientist can do both machine learning development and also big data analytics. So we'll go into the demo part. So we'll have 4 different demos. First, we'll see how a machine learning engineer can create and manage EMR clusters directly from SageMaker Studio. Then we'll look into another demo where machine learning engineer, in case he doesn't have a permission to an EMR cluster and he is expected to use an existing EMR cluster that's already been spun up by data platform teams. So we'll look into how can a machine learning engineer come in and discover and connect to an EMR clusters. Then we'll go ahead and see our third demo on how a Spark job that has been submitted from SageMaker Studio, the ML engineer can directly debug the Spark job from SageMaker Studio itself. And finally, we'll have one demo of running an end-to-end ML model. So we'll try to work on predicting an air quality using weather data. In this, we'll use the feature that we just discussed about how we can do a single notebook for interacting both with big data frameworks and machine learning. Without further ado, we'll go into our first demo. This is the interface for SageMaker Studio, and we have introduced on the left side capability on the left panel for a users to choose called clusters. When user choose a cluster, it pops up two buttons, one for view cluster and other for create clusters. So these are actually an EMR clusters. So as a data scientist coming in, if a data scientist is having a requirement to pre-process a huge amount of data scientist would want to first create an EMR cluster. So let's see how can he create a cluster. So to create a cluster, so we press the create cluster button. So what we see in this interface are specific templates an administrator has made available to the data scientist. An administrator can choose to only make templates available to the team leads in an organization who can create clusters on behalf of junior data scientists. So admin would have few complete capability to create clusters in the organization or give permissions. This is very important capability that I'm discussing because many organizations are very sensitive on who gets an access permission to spin up the compute infrastructure in order to save costs. So data scientists would come in, choose among the set of these templates, and go ahead for creating a cluster. So in our example, we would probably choose this AWS April webinar as a sample cluster. So when we select this template, it is not a complicated interface. The administrator has only exposed certain set of parameters the data scientists need to configure in order to spin this cluster. In this case, you can set the name of the cluster as demo1, okay? And I can choose an EMR release version. So administrator can allow different EMR versions that users can choose, and they can choose the master instance type and core instance type and number of instances. These are set of parameters that administrator allows data scientists to configure. So they can configure these parameters depending upon the size of the data they are processing. So another capability administrator can choose to expose to user is ability to time out an EMR cluster with an idle timeout configuration. So an EMR clusters can be spun up, and when they're not being used, they have a capability to auto shut down when they are idle for a certain amount of time. An administrator can either choose to expose this idle timeout to the ML engineer and data scientist to configure, or depending upon their organization requirement, he can totally set that as a default value. So I just wanted to ensure this as an additional slide just to make sure that administrators of an organization doesn't have to worry about compute resources being idle, and they can configure an EMR cluster to auto shut down. This is one of the recent features that we have introduced in EMR to save costs for our customers. So these templates that offer immense amount of flexibility for an administrator to customize the template creation for a particular organization. So let's go behind the scenes and see how are these templates created. These templates that you see in this interface are created using AWS Service Catalog. AWS Service Catalog enables you to create portfolios and products and customize and deliver to the users. In this case, we have a portfolio with a set of products that is exposed to an IAM role of SageMaker Studio. So let's take a look at an example here, AWS April webinar. This is a product and a template, as you can have a section of parameters. So if you see, I highlight this parameters section. This is the section the administrator wants to expose whatever the parameters the data scientist wants to enter. So whatever the parameters that he wants to provide to data scientists, he would put into this parameters section. And we have so much of other template details for creating an EMR clusters, right? So there are informations like security group, VPCs, network configuration. All these different configurations are guardrails that an administrator cares about a lot, but we don't want data scientists to spend a lot of time to think about, okay, what VPC am I supposed to select? What security group am I supposed to select? We don't want organizations to train data scientists on these specific infrastructure topics. So these parameters that are not of an interest to data scientists can be completely abstracted away by your DevOps engineers, and data scientists can only focus on the parameter of their interest of ML model. So what parameters might be interested to data scientists? He would want to choose, okay, what Spark version I would want, what is the data I'm processing, in that case, what instance type I'm supposed to select. So only those parameters can be provided as an option to the data scientist as part of template, and rest of them about like organization security, whether I'm supposed to use Kerberos protocol or what security group I'm supposed to use. These information can be completely abstracted. So let's go ahead and look our next demo on the weaving the cluster. So now that we created a cluster with a template, so just like a second demo where you weave the cluster and discover EMR clusters in a cross-account scenario also. When you click on the View Cluster button, you see a list of all clusters that are available for a data scientist to choose from. So we have a cluster with an account ending 973, and also we have clusters that's between, that are being displayed with account ending 164. So organizations typically have multi-account setups, and they may have an EMR clusters running in different accounts. Let's say if you have a machine learning or data scientist team which is horizontal across the multiple teams, and you want a data scientist working on a marketing team's project wants to spin up the resources in marketing account, he can choose a cluster in the marketing account. So this is the capability that we want to introduce, wherein which from a same SageMaker interface, customer can submit jobs to different EMR clusters. So we also have an ability to see the details of a cluster. It's not just the list of clusters. So before data scientists choose a cluster, he can look at the details of what Spark version, and there is also an access to Spark server history to look at the different jobs that have been previously submitted to that cluster. So now let's see how we can connect an EMR cluster from a notebook. So this is a SageMaker Studio notebook which is connected to Spark Magic kernel. So now let's connect to the clusters. We hit the cluster button, and this interface displays the list of all clusters that have been available for the user to choose. In all of the different accounts that in particular user has access to choose. Let's say I choose a cluster I want to connect to, and then hit connect button. And then you choose credentials. And the moment you hit connect, SageMaker Studio automatically inserts the code needed to connect to the EMR cluster. So data scientist doesn't have to remember the API to connect to an EMR cluster. So the SageMaker Studio automatically inserts the cluster ID to connect, and we can see it's initiating the EMR connection. And now, this notebook that is connected to the EMR cluster, and we have a link to the Spark UI. So we are connecting to the EMR using Livy, and data scientist can connect to the cluster using an HTTP authentication, Kerberos authentication, or LDAP authentication. So now that we have seen the demo of creating a cluster and weaving the clusters and how to connect to the cluster, let's look into how can this be used by end-to-end model. So in our next demo, it gets more technical, but it's totally fine. I just wanted to tell what we are trying to do in our next slide is we are trying to predict an air quality model using a weather data set for a city, Seattle. So if you have not seen this link, registry for open data for AWS, this is a registry of lot of open source data sets that machine learning can explore on. So we have a lot of different types of data sets available here. So we are taking this data from OpenAQ, the air quality, and trying to predict it with another data set called weather data. So I've already gone ahead and launched my SageMaker Studio. I created my cluster. We're going to walk through this notebook. So one thing I had to do in the course here is any data science and data engineering, figuring out the right version of Pandas. So and then I just ensure that I'm installing 1.05 version of Pandas and ensure that it's right version that's been selected. And we can see it's already connected to an EMR cluster, and we have a Spark UI link available too. So I'll come back to the Spark UI later. At any point in time down the notebook you want to access the EMR cluster, all you need to do is type %info, and it gives you the Spark UI link. Let's go ahead and see the data preparation. So what we're going to do here is we're going to open up a single JSON file and read the schema from that, and then we're going to take schema and use it to read the rest of the data. So we are actually reading the air quality data from year 2000 and later. So, and then in the next box of executing, we are trying to filter down this data for Seattle. So the parameter of your interest is nitrogen dioxide, NO2. The air quality of a city is generally calculated based upon the percentage of NO2 in a particular air. So we have a sample row that has come up already. So we can see in the sample row the list of variables that are available. We have information about the city, and we have information about the date, both UTC and local date. So, and then the NO2 and the meters, it's NO2 ideally in US it's ppm, but rest of the world it's cubic grams per meter cube. So now we can see the data that's filtered down to Seattle City. So we are taking all the data from Washington Department of Ecology sensor, and NO2 as the parameter, and we have the value in ppm. Well, the job is being processing. So now that we are trying to aggregate the data and the job is submitted to Spark, we can take a look at the Spark UI. So now that the job is submitted to Spark from EMR cluster, so this is the Spark UI, and we can see almost 6,400 tasks are running to read 3,500 files there. We can also look into the event timeline of Spark. So we can see the Spark executors that have been added and that have been deleted over the timeline while the job is being processed. So we can navigate to the executor screen. So if you click on the executor screen, it displays the list of all Spark executors that have been processing the job that is submitted from SageMaker Studio. So we can see it's adding the different vCores for different executors, starting from 4, 16, and 20. And if you want to take a look at, we can directly look at the logs also from Spark UI. So the what that we are trying to say here is, so a machine learning engineer starting ML model from SageMaker Studio directly submitted the job to the Spark and debugged the job from Spark UI directly from the same interface. So we have basically aggregated the average NO2 over per day. Okay, so we have converted the millions of records into few thousand records to average our NO2 values over a year. And then, now that we have a data frame with only limited average values, we can directly pull the data frames from Spark into the local notebook. So that's the interface there that you see Spark-O def no average on the top. So now that we have this average data set, we'll try to plot it and see. So this is an NO2 average over the different years, the air quality data over different years. So we can see the date ranges from when to when we have different data types available, and we can see the missing data in around 2018 and 19. So there was no data available from October of 2018 to November of 2018. So we try to, instead of missing the data, we'll try to, a typical data science scientist would come and try to impute the missing data. So we would go ahead and add that data for those dates and fill it with an average values from the previous days. So this is typical feature engineering operation in data science performed whenever there is some missing data. And then we will pull out what is the maximum year in and maximum year and minimum year variables from our data set. Because we want to go ahead and read our second data set of weather. So if you see the variables there sent to Spark, this is when you want to send the variable from our notebook to Spark, you would use this something called send to Spark. So we want to send 2016 and 2022 as our year max and year min. So by just clicking this single API called send to Spark, you can send a variable from your notebook directly to the distributed Spark. So it says successfully passed year max and year min to the Spark. Now we would go ahead and read our second data set of the Seattle weather data over an years, because we have the weather data set for a very long history from 1990s, but we would want to read only for the boundary of an year where we were interested in, because the years where we have our air quality data set available. So we are doing a lot of operation here. So all that we are trying to do here is just trying to read our weather data from S3 and filter it out to only the range of the year that we are interested in, and then trying to replace some of our variables in a readable format, like maximum temperature, maximum minimum, and then impute some missing values. I know this is actually the coding part of data science, but the goal of the session is try to explain how from a single notebook you can interact with both your standard machine learning and also AMR. So what we did from a SageMaker Studio, we directly aggregating the weather data over an averaged over single day. And we can see we are again Seattle features, SCA features is a data frame there that we are using Spark-O. So what would we do? Once this weather data has been aggregated in Spark, now that we have an aggregated data, we'll pull it out. Spark-O is get out from the Spark. So come get the data frame from the Spark. So you're trying to read the data from Spark into your local notebook. So now we have two, so what did we do? We processed two data sets in Spark and brought an aggregated data back to the notebook. So now we have two data sets. We're going to display this data. So this is the maximum. Let's plot. This is the plotted temperature for maximum and minimum weather over the year. You can see Seattle in summer, it gets up to 90 degrees, and in winter, it goes down to 40 sometimes. So average weather maximum and weather minimum. And this is then wind speed over the different years. And then we'll plot visibility. We know Seattle is a cloudy city most of the time. That's why you often see a visibility dropping down extreme low levels. So we'll try to predict air quality with using the temperature, wind speed, and visibility. So now that we have both the data sets, on the top there is a data set for average NO2, and in the bottom we have the weather data sets. So we'll try to merge these two data sets into one single data set, because we want to predict NO2 average using the weather data set. So we do have the different date ranges, so we'll try to ensure that we try to merge it so that we have a uniform set of dates the data will be available for. So we have this merged data set now. So now that we have the data set merged together, we'll do some visualizations on different, if you want to understand more about what's happening in this entire machine learning model is in this blog post. I'll try to show the link of this blog post now, but I can give it as a reference. So this is the air quality prediction model that we are trying to do. You can reference this. So if you can see the wind speed to NO2, we feel there is some correlation. As the wind speed increases, the NO2 level decreases. And then we'll go into the next correlation between the visibility and NO2. If you see the correlation, there doesn't seem to be much correlation between visibility. So visibility doesn't seem to be impacting the air quality. And then we'll see the previous day NO2. How does previous day NO2 impacts the current day of NO2? This is very typical in time series data. Normally, the previous day weather impacts the current day weather. So you see there's a strong correlation. Now that we have this data set and correlation done, we would go ahead and start training our model of linear learner model. So this is the part where we are training the model. So we are using the linear learner library from SageMaker and providing the input data set after splitting our data into both training and test data sets. So once we have the learner, when we call the learner.fit, it's going to start a training job. So the learner.fit would create a training job, and then when we call the training job is successful, that it took 70 seconds of training job completion, and then you can call learner.predictor. So once our training job is successful, we can create a predictor. So when you say deploy, it's going to deploy an endpoint for prediction. So in our case, we can call, it is a very so simple API called deploy, which is directly deploying an endpoint for deployment. So we would go ahead and reuse this deployment that have been already deployed. So it's a deployment endpoint and try to test the values, compare the predicted value against the actual values. So these are our variables of our linear root mean square error of our linear and variance score of our linear learner model. And finally, we'll look at the forecasted versus actual. So if you can see, the air quality depends on the weather. And it's mostly, we are predicting very accurately, except that one of the couple of outliers where we see it's very high value on those forecasted versus actual. So that comes to like end of our demo. It's totally fine. I understand the last demo has so much of code over there, but the intention here is to show how from a single notebook interface, you can do both big data processing and machine learning. So what exactly have we done here? So we created a notebook. From the same notebook, we connected to an EMR cluster. We read the data from S3 and aggregated it in the Spark. And then once the aggregated data, we pulled it back to our notebook. And once we have two data frames, we merged it and performed the machine learning model. So that's why we call how we can simplify our end-to-end ML workflow without having to move across different tools. Everything can be done from one single SageMaker Studio. Sorry, I'm not going for next slide. Perfect. So that ends our session. We highly encourage you to use our AWS certification and also AWS digital courses across this summit. And I'm happy to take any questions we have. Yeah, can I have a mic there?
Is it on? Okay. Hi. So I want to check, like, after the model is created, so if I have to deploy it, will it go to like SageMaker directly and it can be like sent to MLOps team so that they can manage in production? Or is there a separate process for that?
Okay, so the question here is, so when you after call deploy, what happens exactly,
yes.
right? So deploy is an API to deploy the model that you've trained. So when you call deploy, you are deploying it to an endpoint to reuse the deployed model, right? So in SageMaker, we have the model endpoints. Endpoints is where you want to test, like you can reuse the model for multiple runs, right? So it basically creates an endpoint. So in the SageMaker console, you can have a screen called endpoint, so it will create an endpoint there.
Okay, got it. Thank you.
So whatever you see .deploy is from SageMaker. Instead of going to console with an API, you are trying to deploy the.
Yeah, that's what I wanted to check. Another question I have is like you pulled the variable value from the Spark back to your notebook. So you can pull like multiple variables, or you can just do one.
No, you can send multiple variables. So whatever the variables that you want to push, you can push it to Spark, and whatever the Spark data frames, as long as they are not huge, that you can fit in your notebook memory, but the single Spark-O, you can pull those data frames back to the notebook.
Okay, that's great. Thank you.
Thank you. Good presentation. I have two questions. One is in relation to the part where you start training the machine learning. Does that run in the cluster as well?
So the machine learning model training, right? So we use the EMR cluster only to process the data. So we had this air quality data with the minute level of millions of rows of air quality sensors. And also we have weather data collected from different sensors. So we use EMR only to aggregate and average these data over a day, right? Now that we have these both aggregated data frames, we pulled it back to the notebook, and then we use the machine learning model called linear learner.train, right? So it's creating a training job, and this training job is not in EMR cluster. This is a training job running on a separate compute infrastructure in SageMaker.
Right, but wouldn't it make sense that because the computing, let's say you have a more involved model like deep learning, that takes a lot of compute power.
Yeah.
Wouldn't you leverage the cluster environment to maximize the?
Yes, definitely you can do that. So here in our example, we just used because our aggregated data set was only for 1,000 dates. We use the infrastructure of only SageMaker training job. But if you have the huge amount of data set, when you submit linear learner.train, there were a bunch of parameters that we passed. So one of those parameters, you can choose where or what compute you want to run this training job on. So even you can choose the GPUs to run your deep learning model there.
Okay. Just one more question. So in our environment, we have a dev environment. We use a VPC that is different from where the production environment is. Can we decouple the two, let's say, train the model in our environment, but deploy without creating dependency on SageMaker libraries?
Yes, you can do. That's the reason I showed, right? But is your dev, you have different AWS accounts for your development and prod?
Yes.
Right? So in that case, you are training your job in development, but you want to deploy the job in a production account, right? So I think you can do a cross-account deployment. I would probably look into this and probably, I'll get back to you on it, but I'm pretty sure when you call deploy, you can provide a cross-account deploy, but your dev account needs to have permission to do a SageMaker deployment, what is called, in your production account. So you'll have to create this cross-account IAM role.
Okay, thank you.
Hello, I'm a data scientist. I have built the machine learning model using SageMaker. So can you tell me what's the best advantage of using SageMaker Studio instead of SageMaker?
Okay, so SageMaker, when you go to SageMaker, it has different things, right? You have notebooks, you have training jobs, and so if you want to use a notebook, you need to first create a notebook interface. And basically, SageMaker Studio is an integrated development environment where you can use entire SageMaker features from a single place. There's no lot of, SageMaker Studio is basically an IDE. If you have a Java developer, how you use an Eclipse IDE. As a SageMaker, you log into Studio, and you can do everything. Like you can submit a deploy job, you can submit a training job, and you can submit a monitoring job. So Studio is mostly an interface, is a visual interface for the different features of SageMaker.
It's have more different like a much bigger container which have.
Yeah, it's mostly of
But not
flexibility to use. It's flexibility to use and ease of interface. It's mostly just an interface trying to integrate the different features of SageMaker that you can use directly from one studio.
Okay, not in terms of the development processing, because I still have to write codes in Studio
You
or
still
in
have to.
SageMaker. It's the same thing.
If you
right?
don't want to write a code, good question. So we have another feature called SageMaker Canvas nowadays. So it's what is called no-code machine learning. Okay. So I wish we had a session. If there's any session, I can look into it. But please Google something called SageMaker Canvas. So it's like with a just drag and drop, we can define the machine learning models.
That might be much cooler, because
That's much
writing
cooler,
code, I have to figure out what's your the syntax and everything to plug in and then copy paste. But if you have a jog paste,
Yep.
it's like some products, model building products divided by 5 code. They have like a
Exactly.
model
So
building
I would
tradition.
want you to Google SageMaker Canvas for that.
Okay, so right now, because we have not integrated data to the warehouse, we are doing that data integration from the SQL to the AWS Redshift. But when I develop the model, I have to manually load the data from SQL and upload using a CSV file to the S3 container. But once I develop the model and I deploy it in endpoint, and in the future when the data migrated to Redshift, so I can directly access Redshift from SageMaker, right?
Yes,
But I think right now I couldn't do that yesterday. I tried because I think maybe there's a network is not set up yet for the VCP.
VPC? Yeah.
VPC, right? So we should set up VPC. That's the only thing that we should set up.
That's the only thing. So you should ensure that you open the connectivity to a Redshift cluster from SageMaker Studio Notebook. Once you open that connectivity, you should be able to connect using Python JDBC, or else, as I shown in your EMR cluster, you can always use Spark. There's a Spark connector. Spark can read from Redshift too. So you can use an EMR cluster to read the data from Redshift. But what is I'm interested in your use case where you want to read the Redshift data into the notebook memory and use it, or you want to do some big, huge aggregation processing?
Just the production. I mean, it's not. I mean, it's the new, the future one is like we access the Redshift using SageMaker. They just score the file right away, and my last question is, how do we save the data? Should we save the output in S3, or should we save the output in Redshift?
Which output? Your model output?
The model, the model score.
The model score.
Yeah,
okay.
the model score.
So whether to read data from SageMaker to from Redshift to SageMaker, or write data from SageMaker to Redshift, you need to open that VPC connectivity to Redshift, and you would have to connect to the Redshift cluster. So let's say if you are using Python libraries from Redshift, you would have to connect using JDBC, I guess.
Yeah, but when in the production, real time, with the production, the model score, should we save it in S3 container, or in just read back to the Redshift, save it there?
I think you currently, I don't see this direct integration to Redshift yet, so probably you'll have to write it to S3 and load it into Redshift.
Okay, you just write the model score back to the Redshift.
S3.
Okay, good. That's what I want. Thank you.
Cool, thank you. Please use your app and please provide feedback on the session. Thank you. And this is my email ID. Feel free to send me if you have any further questions. I'm happy to answer. I think, can you please email me this question that you asked, because I'm not confident if I really got it. I would be happy to answer you a detailed email. And in your case too, it's I was able to answer your question correctly, or?
I do have more questions, but yeah, we can take it offline.
Definitely, yeah. Thank you.